Well, ladies and gentlemen, our next session will bring together leading experts to explore the heat cooling paradox, examining the gaps in scientific understanding and technology deployment. This discussion will also address the growing challenge of rising heat and the increasing global demand for cooling solutions. Yes, requesting Mr. Bapna to stay back on stage. Oh, all right, okay. Ladies and gentlemen, I'm delighted to invite our esteemed panelists to the stage. First, please put your hands together for Dr. Radhika Khosla, Associate Professor and Research Director, Oxford India Centre for Sustainable Development, University of Oxford. She leads Oxford's Zero Carbon Energy Use Program at the Zero Institute and is the principal investigator of the Oxford Martin School's Future of Cooling program. A very, very warm welcome to you, ma'am. Yes, please. Be comfortable in your seat. I will again request you once this is done. We'll just take a moment. Till that time, allow me to introduce all our speakers. Next, ladies and gentlemen, Dr. Roxy Matthew Call, climate scientist, Indian Institute of Tropical Meteorology. He has made breakthrough contributions to the research, monitoring, and modeling of climate and extreme weather events over the Indo-Pacific region. A very, very warm welcome to you. Up next, Dr. Joy Shoemake, lead World Health Organization, World Meteorological Organization, Joint Office for Climate and Health. She's an environmental health scientist and public health practitioner who has worked with WHO, WMO, UNICEF, and others to develop public health policy and programming for climate adaptation and risk management. A very warm welcome to you. And a round of applause for Dr. Joy Shoemake, ladies and gentlemen. Up next, Mr. Amit Prathy, Director General, Coalition for Disaster Resilient Infrastructure. He's an international expert with nearly 25 years of progressive leadership in the fields of urban planning and resilient infrastructure, with experience across more than 15 countries in North America, Asia, and Europe. A very, very warm welcome to Mr. Amit Prathy. And yes, now, with a round of applause, let's welcome our moderator for the panel discussion, Mr. Bapna. All right. Well, everybody here is eagerly looking forward to the conversation, to the discussion, and of course, to those insightful insights which we're going to get from all our panelists and our speakers. All right, till the time Mr. Bapna is here, let's move into the discussion. As first, I would like to invite Ms. Radhika Khosla to enlighten us on current trends in rising heat and demand for cooling, gaps in scientific understanding, and challenges and risk. I would request you, ma'am, to join us on the podium. A very warm welcome. Thanks very much. I'm trying to find a spot where I can see the slides as well. Maybe like this. Okay, I'll turn around. Great, thank you for having me. Thank you for having me. It's wonderful to be here, and I'm really glad that we have this week actually ahead of us to be able to think through some of these questions about heat and cooling and the paradox that they give rise to. What I'd like to do in the next few minutes is just talk a little bit about the science around the heating and cooling question, and just lay forth some of the latest research that we've been doing and seeing.
So if somebody can give me the next slide, please. Yeah, so just to start out, we're at a place right now where if you look at the top left here, I like this figure because it shows us that no matter where we are, whether we are sort of born in 1950, in 1980, and have children born in 2020, or whatever it might be, the world looks very different if we move forward from here on vis-a-vis how it looked when we reflect back. And even in the best case scenario, we're looking at temperature rises that are much warmer than what they've been in the past. And that has a very different implication for what warming is going to look like at the global level and at the local level. Now, of course, a direct implication of that is the rise in extreme heat. And I think it's important for us to remember that extreme heat kills more than any other extreme weather event. So more than droughts, more than floods, more than wildfires, extreme heat is the largest killer of all extreme weather events. It's also very silent. You don't have before and after images in the same way. And of course, our go-to solution over the last, sort of 100 years or so has been the development of an air conditioner. I like this figure on the right as well because it reminds us that actually by the end of the century, the energy consumption from air conditioning alone is going to be more than that from global heating demand. And that's particularly stark when we think about the energy discourse so far, which has really been, it's been dominated by ideas of heating and how we're going to stay warm in colder climates. All of that is going to change. Lee Kuan Yew reminded us when he was asked what made Singapore successful, he said it was actually air conditioning, because air conditioning changed the nature of civilization by making development possible in the tropics. And I think that's true for all of us. It's true for us here. It's true for us in many parts of the world where air conditioning has made life habitable. At the moment, global cooling takes about 20% of global electricity use, which is a pretty high number given, just given that actually large parts of the hot world still don't have very high air conditioning use. Another thing that's really stark is that, all these numbers we've heard in the previous session as well about the rise in air conditioning, the, sort of IEA statistics of 10 new air conditioners every second for the next 30 years. In spite of that rise, the cooling gap in 2050 is going to be 2 to 5 billion people will not have access to an air conditioner. So this is not just an issue about heat and cooling, it's also an issue about equity. And actually it's tied to each of the different sustainable development goals, even though the word heat, cooling, thermal, refrigerant do not appear anywhere in the United Nations 17 SDGs and their 169 targets. Next slide, please. So I just want to show you some of the figures that set a global context for this conversation we're going to have over the next week. So we did some work where we said, we know that the world is warming very quickly. It's moving from a 1.5 degree warming, which, frankly could happen anywhere in the next few years, to a world that will probably be 2 degrees hotter than the pre-industrial days. And where is the largest absolute change in cooling demand going to come from? And when we did that, what we found was that it is the countries in Africa that see the largest absolute change in cooling demand as we move from a 1.5 degree world to a 2 degree world. And actually India is really up there as well. It's not in the top 10, but it's definitely in the countries that is top ranked. And and you can see like the red portions of what the earth is going to look like when we do that. We then ask the question, what does it mean in terms of relative change? So if we move from a 1.5 degree world to a 2 degree world, where do we see the largest relative change in cooling demand? And when we did that, the figure turned on its head, and you actually see that it's mainly countries in Europe, in the north of in North America, that see this very large change in cooling degree days, which is an indicator of cooling demand. And it's Switzerland, the United Kingdom, Norway, Finland, Sweden. These are the countries that are seeing very, very large increases on a relative basis as the earth warms in its global mean temperature, telling us that this is no longer an issue that is confined to hot climates. It's no longer a tropical issue. It is actually an issue that is going to affect every part of the world. And we have to be able to be prepared to have these kinds of global conversations about what happens to people when they're exposed to levels of heat that many parts of the world are just not prepared for, and particularly these colder parts of the world have never really considered as being something that is salient to their own context. Now, cooling degree days and cooling demand is it's an indicator in some sense of the hazard, right? But what is risk? Risk is a function of the hazard, the exposure to that hazard, and the vulnerability to be able to respond to that hazard. So then what we said is, okay, we have this cooling degree days, we have this cooling demand and this heat stress that is hitting different parts of the world, but where is the largest population exposure to that heat? And when we did that work, of course, the country that comes up as number one is India, and that's where we see the largest number of people are going to be exposed to this very large demand in cooling. And this raises really important questions for all of us here in terms of how we're going to respond to this level of heat that is coming upon us in a context and in a cultural context where we actually don't see heat as such a bad thing, right? We feel we've lived with it for a long time. That makes us somewhat agnostic to how we might respond, and that this heat is very different, and the population exposed to this heat is going to be very different. That raises all kinds of questions for adaptation that that we're going to be talking about. One more thing that I think is important to note is that in this work, what we found is that actually the level of increase in heat stress and the increase in level of cooling demand is going to be much higher between now and when we hit 1.5 degrees of warming than when we move from 1.5 to 2 degrees of warming. And what that means in terms of, again, our adaptation, our ability to respond in terms of building resilience and otherwise, is that we have to do a lot more work up front. We have to do a lot more work now to be able to prevent and help individuals save lives and help economies than we would have to do later on. Not that we'll have to do less than, but there's a lot more to be done up front that we need to be cognizant of. There's a little bit of, here about what this means in the Indian context. I won't spend too much time on this right now, but when we've been looking at some of the numbers, from the last 4-5 years, and, it's just low. The level of AC penetration and ownership is low. It's less than 5%. It's mainly in the urban areas. It's rising very, very quickly. There's a distribution between the states that are wealthier, and it's not surprising, but Punjab, Chandigarh, Haryana, Delhi, Gujarat, Goa, they have very high rates of AC ownership, much lower in the Northeast, and most of this AC ownership lies with top income deciles. We're also doing some work where we're trying to understand, what is the ability to be able to react to the hazard of extreme heat given the economic conditions of different states. And there we're able to see a lot more granularity at a 1 kilometer level within states. And this is work, that applies to anywhere in the world, right? It's, of course, you have country level data, but what happens within regions, what happens within cities, and to be able to disaggregate that is going to be an important next step from a scientific basis in terms of how we handle this. So I see time's up, but I just have a couple more slides. I think this is important. This is work we did for the Global Cooling Watch report, which was the UN's first spotlight report on cooling, and I was the lead author for that. And I just want to focus on one main message from this big study, which was to say, our goal was to say, look, the Earth is getting warmer, heat stress is rising. We're going to be in a world where most people will need an air conditioner. How do we get to a world where you have thermal comfort for everybody, but we do that without killing the planet? And so the goal was to say, can we get to a world where we actually have zero emissions cooling? Because if you have zero emissions cooling, it's actually not such a bad thing. We kind of, we've met our goals. And the good news was that we can get there. How do we get there? There are 3 ways in which we get there. One is by an immense emphasis on passive cooling reduction, which I'm sure we'll talk about. The second is a real focus on energy efficiency and minimum energy performance standards of technology that are regularly updated and harmonized. And the third is to phase out refrigerant gases. I won't go into the details of all of that right now, but I want to put those three things on the table and also say that that takes us to about 66% reduction in emissions for 2050 cooling emissions, and that last third of emission reductions comes from decarbonizing the grid. And in a way, the fact that air conditioners run on electricity is a gift. It's a gift because it allows us to be able to rely on a grid that can be clean, which is not the case with heating, where we're working with oil and gas and other such fossil fuels. And I think it's important to remember that opportunity lies with us. And my last slide is just to say that we can have a very technological conversation, but in the end, it is human beings we're interested in. We're interested in in cooling people, not buildings, and placing humans at the core of cooling needs is really important. And so in the way that we think about this, cooling poverty is a really important issue, but cooling poverty is systemic. Cooling poverty is not whether you have access to an air conditioner or not. Cooling poverty is whether you have access to infrastructure. For instance, do you have access to green spaces? Do you have access to shading? Do you have access to water bodies? What are your health conditions? Do you have propensities to certain kinds of diseases that are particularly cardiovascular diseases that get very amplified in the extreme heat? And what are your levels of education and work standards? And of course, what is your exposure to humidity? So, it is a much more complicated and multidimensional issue. And in the conversations that we're going to have, I think it's really important for us to recognize that we're dealing with something that is interconnected with multiple priorities, with multiple goals, and we need to be able to negotiate those as we think through how we're going to build resilience to extreme heat. Thank you.
Thank you, Ms. Khosla, for the detailed presentation. And it's time that I now hand over the stage to Mr. Manish Bapnar, who's a moderator for the first panel discussion.
Great, thank you. Great, so look, we have 40 minutes? Okay, so what we're gonna do, we're gonna try to really create a little bit of a conversation here. I'm gonna ask each of you two questions, 8 questions, 40 minutes, brevity will be appreciated. If you want to jump in on what someone else has responded, just signal so we can make this a little bit more organic. About 2-3 minutes before we end, I'm going to ask each of you to, I'm giving you a little heads up here, I'm going to ask each of you to close with a sentence on the kind of most important message you'd like to leave the audience with. Yeah, so just we'll try to make this fairly fast-paced. Because there's a lot to cover. And Roxy, I'm going to start with you. Indian Ocean. I'll just probably go down in order if that's okay. Roxy, Joy, Amit, and then I'll come back to Radhika. But the Indian Ocean's role in the global climate system is incredibly important. Just tell us a little bit more about the role of the Indian Ocean and what some of the recent warming, the feedback loops, what does it mean for the climate projections that we are talking about?
Thanks, Manish. Thanks to NRDC, NGMA, and World Bank for this wonderful gathering on discussion. I would start with my message first.
You'll have to come up with another one at the end, but
yeah, another one. Okay, cool. What I would say is that heat should not be treated in isolation. Yeah. So whether it's the science and mechanism of how these heat wave events happen or their impacts, yeah, it should not be treated in isolation. I'll give you the examples. So the science and mechanism, that's where the Indian Ocean warming or the ocean warming and the large-scale climate system matters. Yeah. For example, I'll take the case of year 2022, just a couple of years ago. And we had one of the longest heat wave season. Temperatures in Delhi crossed 50 degrees Celsius, Pakistan 51 degrees Celsius. Yeah. My kids were going to school that time after COVID, and they were hit with the heat stroke kind of conditions. Just like the minister said, my kids were, they were coming back from school at peak heat wave time, 2 to 3 p.m. And this is in Pune, mild temperatures generally. Yeah. So this year, so this is April-May season, the heat wave season, pre-monsoon, before the monsoon. It was not just a heat, but also a delayed monsoon, deficit rainfall. Yeah. So that's where the large-scale climate system, ocean conditions, a warm ocean condition generally weakens the monsoons and the rains that you get over the land. Yeah. A deficit rainfall, then a heat wave condition. So deficit rainfall means less water. Groundwater is also depleted. It's almost drought-like condition. Monsoon was delayed, so the agriculture also suffered. And there were wildfires. All on top of that, air pollution as well. So this is a set of overlapping events along with the heat. We see this very often during the pre-monsoon season, that's the peak summer season. And this is connected to the large-scale climate system, the Indian Ocean and all. And we call these compound weather events. Which means that if we need to understand heat and impacts, so that year, several lives were lost. Our agriculture was hit. Wheat grains, the farmers reported that the wheat grains were 20% less size. And we stopped our exports. India is the largest exporter of wheat, and we stopped our exports for a while, which means that agriculture, our livelihoods were also hit during that time. And very often, whether it's scientists, policymakers, or whether our monitoring forecasting system, all of these systems, frameworks, treat these extreme weather events in isolation. These scientists study them separately. Similarly, we all treat, this is a heat conference, but many times we see that overlapping events are important. And there are cascading events as well. I will come on that later, maybe sometime. So if you are to frame policies, if you are to have predictions, projections, and policies framed for the country, we need to not just treat heat as in an isolation, but combine all these factors. And all of them are going up, whether it is the heat, whether it is the change in rainfall patterns. There is drying in some parts of the subcontinent. Wildfires are going up, air pollution is going up. So we need to consider a comprehensive outlook, whether it is for forecasts or predictions. That's my current message.
That is sobering, but clear. So very much appreciate that. Joy, if I could turn to you and maybe just a sentence or two, a little bit about where you're coming from, what your organization does, maybe a word about GIN, and then the question, just because I think it's important for the audience to be aware of where you all are coming from and what you're doing. But then I'd love to get a little bit more deeper into, from a public health standpoint, what do you see as the priorities for protecting vulnerable communities from extreme heat, getting into the social kind of equity questions that we've been talking about?
There we go. Yes. Great. Well, thank you again so much for the invitation. It is an absolute honor to be here with you all today. I'm coming from the World Meteorological Organization in Geneva, where I lead the Global Heat Health Information Network, which is a global community of practice of scientists, of NGOs, of policymakers who have come together actually almost 10 years ago now, because we are concerned about this grave nature of this crisis, of this cycle that we are in between the cooling and needing to address the risks of extreme heat. And so I'm here to learn with you and share with you some of the global lessons from that community. And from the World Meteorological Organization, it is our members, the national meteorological organizations, like the Indian Meteorological Department, who have been telling us and measuring for decades the trends of climate change. the trajectory of the warming temperatures that we are experiencing. We have known this for decades. And science has been showing us that this is a certain future. The first graphic from the Intergovernmental Panel on Climate Change that Dr. Kozla showed us shows that we are locked in to a warmer future. How hot it is going to be is the choice that we have in front of us. But we have already heard that climate change and these warming temperatures are sabotaging sustainable development. And it is not only the impacts on health, but on economies, on businesses, on infrastructure, on the water and food systems that we depend upon. And so it is the hard choice that brings us all here today of how do we slow climate change and at the same time adapt our society and the way of living to these warmer conditions. And so the real question for me is, what does it take to shift our society, our politicians, our communities to be able to respond to these projections? Is it just more science? Is it demonstrating the severity of the impacts? What is that actually going to take? For me, I think it really comes down to us as a community being able to demonstrate what works. These win-win solutions that we've already heard about in the first hour of this conference. We've heard of dozens of solutions that are working, that are the early warning systems that are telling communities when they're at risk and what to do. How do we protect workers? How do we have more heat responsive water, energy, and housing policies? How do we prioritize where green and blue space can cool our communities? We've heard of these solutions and we need to be promoting that even further, even faster. Because of course there will always be knowledge gaps, but it's not necessarily more science that's going to help change the behaviors, change the beliefs, change the values around how we're addressing this issue. And for me, when I think about this moral dilemma that we're faced with, I think about the parallel with air pollution. Because today we know that air pollution is terrible for our health. 7 million people are dying every year because of their exposure to air pollution. We know that it causes all kinds of chronic and acute health problems. But we didn't know this 50 years ago when we were making transport decisions, when we were making urban planning and energy decisions that would lock us into a future that is today polluting. So the question is, if we had known how terrible air pollution would be today, would we have made different choices as a society? And so as we are sitting at this rising curve in temperatures, what are the different choices that we have to make today of how we are going to confront this balance between this cooling demand, the need for not only thermal comfort, but thermal safety, and a low carbon future? That is what brings me to this room today, to learn with you and from the innovation that is happening in India, that the rest of the world is looking to you to learn from you, because India is a leader in thinking and doing to address this issue.
Thank you so much, Joy. You mentioned a little bit about what works, how we scale solutions. We heard earlier a little bit about SHIELD and the integration of climate risk into housing. Amit, kind of a nice segue to you, and if you could say, for everyone may not know about CDRI, but maybe you could say a word about CDRI and how you're looking at integrating issues around extreme heat, around cooling into infrastructure. What is CDRI doing on this issue?
Thank you so much, Manish, and it's good to see you again. I think we were having a similar conversation in Sharm el Sheikh on heat. I think, first of all, CDRI, for those of you who may not know, is an international organization seeded by India. And we now have, I'm very proud that today we've got the 43rd country that has just announced that they joined CDRI, which is New Zealand. So we actually have now 50 members, global members who are part of this coalition. The focus is on disaster resilient infrastructure. That's the broad focus. And we are in the capacity building and technical assistance space. I think coming back to what we are trying to do, maybe I'll for a minute put my hat of the DG away and put my hat of the urban planner back on, because I've spent about 30 years now in the urban field. And I'm going to pose a challenge to everybody in this room, frankly, because I've now seen green spaces as a solution being put forward for the last 5, 7, 8, 10 years. But I've not seen the next iteration of that. I've not seen the discussion get into green spaces are incredibly expensive. When you start to think about where in an urban setting you have the problem of heat island effect, it's in the places where green spaces are impossible. So yes, you can have more green spaces. Green spaces take more time to establish unless you can protect them. If you protect them, there's a land value associated with this. Who pays for it, right? So I am really my last statement really be, let's move from solutions 1.0 to solutions 5.0. Because the speed at which we need to rethink what we're even proposing today and what this group is still proposing has to be really, really, really turbocharged, because the problem is here today. When we heard the madam from DST talking about the scale of urbanization that's coming, India is going to be building something like, I was hearing 1 Chicago a year amount of infrastructure. Have we learned our lessons already that we can actually build that in a new way where we're not actually going to see the urban heat island problems of today? I'm sorry to say, but I don't think we have. And I think it is really up to all of us, because if this room doesn't have the experts, then where are the experts, right? So I think for me, part of the responsibility of this coalition also is how do we spur innovation? How do we and I would encourage NRDC as well, when you're doing your heat plans, dig into that green space. Don't just leave it as have more green space, but dig into it, unpackage it, because that's really how we'll start to address the problem. CDRI is trying to do that in the infrastructure space. So we launched a call for proposals inviting cities to see how you could innovate with maybe more data, but let's say early warning that is unique for the power sector. Early warning that is unique for the hospitals. So IMD might issue the warning, but somebody needs to now translate that into a decision support system so that the hospital is better prepared, so that the power utility is better prepared. Because if you have ACs and you have no power, it doesn't matter. If you have no power, you have no water, right? So they're coming back to the point of integration. So I think we really need to get much more thorough in our analysis as well as our advice. We're pushing the boundary beyond what we're already saying. I think what we're already saying is we're already putting us behind. Not a very good message, but I think let me.
I appreciate the very kind of candid kind of assessment about where we are and therefore what we need to be tackling straight on. Radhika, I'm going to give you an easy question. I'm going to say maybe a few more words about what you're doing at Oxford, the Oxford India Center. But your presentation was so rich. I actually would love for you to just, if you wanted to again reiterate kind of 2 or 3 of the themes that you think are most important for this audience to be reflecting on. A little bit more on some of the data. How many people have access to any form of cooling technology? We heard a little bit about ACs, but less so about coolers and ceiling fans. If any of you have data on that, that would be great. Another data question is the accessibility of the data. How do we get scientific level data in a format that is usable by the government? And then a question a little bit about, we've been talking about 1.5 to 2 degrees, but the reality is the world is on a trajectory at the moment that 3.2 degrees, if not more. How do we think about heat and cooling in that scenario. So, Roxy,
I can start about the data while,
yep. And we're going to
while
keep
these three think
30
about the cooling.
Yeah. And if we could do 30-second kind of responses, super.
30 seconds, yeah,
that'd be
fast.
great.
Yeah. So I think I'll reframe that question. The question was, how do you get the scientific level data in a consumable format to the government? I would say format to the public actually, because most of the data is actually to the government. And I would say publicly funded data should be in the public domain under FAIR principles. FAIR, free, accessible, interoperable, and R4, what's it? Reproducible. Yeah. So, but we don't see that happening. Yeah. And we need to push the government for that. In fact, the government in 2022 brought out a data policy that all publicly funded projects should be providing this data to a central data server and so on, but it has not been worked out yet. Yeah, that is one thing. And just to add on what Radhika said a bit ago, there is one beautiful way of collecting this data, especially in remote areas, that is through citizen science networks. I have been working with schools, educational institutions, and so on. And I see school kids in an assembly in the morning say, okay, in the last 24 hours, this was the maximum temperature, minimum temperature. So you can train your working hours, school hours according to that. Yeah.
Beautiful. Thank you, Roxy.
If I can
Joy.
quickly just add 2 more points to that, because I was going to make the same ones around citizen science and open access. But the importance of aggregation. There's a lot of data out there, but we're not actually capturing and aggregating it. And these aggregating mechanisms are really, really important. And then the role of research and universities in tailoring the information to make it more decision specific is really important.
Thank you.
I think I'll take the last one, which is, I won't talk about the 4 degrees, but all of us are already paying for it. Because if you think about how heat is affecting, it is affecting your worker who comes to your house. They may fall sick more. And if you're living in Delhi, you probably saw that last summer already. You're talking about infrastructure. One of the things that we are looking at is how disruptions to services, because of, could be heat, could be flood, could be other issues. How many times is that happening? And how do you reduce that over time, right? So I think when we talk about loss in economy, we need to start linking it to your own personal loss that you may already be suffering. At the same time, because I work in the infrastructure sector, how is infrastructure getting disrupted? Whether it's 1 degree, 2 degrees, how do you minimize that disruption so that you're actually not losing the disruption days are reduced? That's what we talk about resilience. When we say resilience, is try to reduce disruptions to the services that are getting impacted because of whether 1 degree is whatever it is. So that's then translates into invest in improving your infrastructure, make those marginal improvements. And if you do that and you reduce your disruption, that becomes a resilience dividend over time. The cost benefit analysis should actually take into account what are the disruptions over time because of all these hazards that you're not factoring in today. And if you can start to factor them in, and there are methodologies now starting, this is another conversation, but it's actually heading towards resilience dividend. Why do you need to invest in these things today to gain long-term, reduce disruption of services?
Thank you, Amit.
I'll be very quick. So just on that question about fans and coolers, when we looked at some data for Delhi for a few thousand households, and what we found was that, fans are pretty ubiquitous. They're sort of across most urban areas. It's one of the first technologies or appliances that homes buy. It's the AC cooler relationship is more interesting. What we see is that initially homes at lower income levels buy coolers, but as income levels rise, you switch to an air conditioner. And actually what's happening is that you're seeing a decline. It's almost like these 2 curves cross each other, where you see a decline in the cooler use as you get to about sort of, the 50th income decile, and then the cooler use, the AC use just rises up. So we're kind of almost replacing one technology with another.
And and the risk of that is very high because we are urbanizing, income levels are rising very quickly, and so we might even just phase out the cooler, which is not something we want.
Okay, so we're going to final round, one sentence each. Last message for the audience. Amit. Oh, just with the mic.
Solution 1.0 to 5.0.
Focusing on these win-win solutions. We have solutions.
Put on many messages, but one message would be we can frame all these actions in a future-oriented way. We should not make solutions just based on our past, what happened with respect to heat wave. We should be future-oriented, and we have the capacity to do that.
And I would say, solutions are not just technological; they're social, they're cultural, they're institutional, and it's really important to draw on that array of what is in front of us.
Please join me, a really warm round of applause for Radhika, Roxy, Joy, and Amit. Thank you. Thank you very much.
I want to thank Joy because she has sat through that jet lag. She just arrived today morning and still answered all your questions. Thank you, Joy.
Thank you so very much to our distinguished panelists and our moderator for having such an engaging panel discussion.